A system is represented by a signal flow graph shown in figure. Obtain the overall gain of the system using Mason's gain formula. R of S is the input, C of S is the output. So how many forward paths are there? This is one forward path. One-way traffic, one forward path. Another one is two forward paths. Any other forward paths? We cannot travel through G9 because it is against the direction. We cannot travel through G6, that is also against direction. That's all. Only two forward paths are there. Similarly, we cannot travel this way also. This way also we cannot travel because G10 is this way. This is G1 is this way. Self loop. Now let us write the Mason's gain formula. P of S equal to 1 by delta sigma Pk delta K. Two forward paths, therefore K equal to 2. P1 equal to what? P1 equal to first forward path. Gain products of first forward paths. G1, G2, G1, G2, G3, G4. That's all. G1, G2, G3, G4. Delta 1 equal to the part of graph which is not touching the forward path is this is the part of graph which is not touching the forward path. Therefore, that is equal to 1 minus the loop in that part of graph which is not touching the forward path is G7. Therefore, 1 minus G7 delta 1. What is P2? P2 equal to the second forward path G1, G5, G1, G5, G8, G4. Delta 2 equal to what? Delta 2 equal to the part of graph which is not touching the forward path is this node alone. In this node alone, there is no loop in that node. That's why only one. What is delta? We have to find delta. Delta equal to 1 minus sum of gain products of individual loops. Loops are L1. This is loop 1, loop 2, loop 3, loop 4. Loop 1 equal to what? L1 equal to G1, G2, G9. L2 equal to G3, G4, G10. L3 equal to G5, G6. L4 equal to G7. L4 equal to G7. L4 equal to G7. Now, G1, G2, G9, L2 equal to G3, G4, G10, L3 equal to G5, G6, and L4 equal to G7. One minus all individual loop gains we have to write. G1, G2, G9 plus G3, G4, G10 plus G5, G6 plus G7 plus gain products of two non-touching loops. G7 is L1 doesn't consist of G7, L2 also doesn't consist. L3 also doesn't consist, but they are touching each other. Therefore, L1 non-touching loops are L1, L4, L2, L4. L2, L4, and L2 and L3 also, there is no common gains. G3, G4, G10, G5, G6. No common gain. And they are not touching, therefore L2, L3, L3 also not touching each other. No other loops are not touching each other. Now there is no three non-touching loops. That's all. Therefore, we have to write L1, L4. L1 is G1, L, G1, G2, G9, G7 plus L2, L4, L2, L4. That is G3, G4, G10, G7 plus L2, L3. G3, G4, G10, G5, G6. No other. That's all about delta. Therefore, by substituting this in the formula, the transfer function is T of S equal to numerator G1, G2, G3, G4, 1 minus G7 plus G1, G5, G8, G4 multiplied by 1 divided by delta. 1 minus G1, G2, G9 minus G3, G4, G10 minus G5, G6, G5, G6 plus G7 minus G7 minus G7, then plus G1, G2, G9, G7, two non-touching loops, plus G3, G4, G10, G7, plus G3, G4, G10, G5, G6. That's all. This is the required transfer function. The denominator starts here and ends here.